Now when we studied about refractive index of one medium with respect to another medium, we said that it is the ratio of sine of angle of incidence to sine of angle of refraction. But we may not always know the angles of incidence or angles of refraction. In that case, how will we find out that what is the refractive index of a medium? So for that, we have another alternate formula here. Now how this formula came into being, like how is it related to with sin I and sin R, that you will be studying in higher classes. But right now, what you need to know is that the refractive index for any medium is equal to the speed of light in vacuum, which is c, that is 3 × 10⁸ meter per second, divided by speed of light in that medium whose refractive index we are finding out. So if I am like finding out the refractive index of water, say I am finding out mu water, refractive index of water. I hope you remember this symbol is called mu. So mu of water will be equal to velocity of light in vacuum divided by the velocity of light in water. So this will be equal to 3 × 10⁸ meter per second divided by 2.25 × 10⁸ meter per second. So the refractive index of water is equal to the ratio of speed of light in vacuum to speed of light in water. And if you do the calculation, this comes out to be 4/3, which is equal to 1.33, and so on it goes. So from here we get to know two informations. First of all, we get to know is that refractive indexes have no unit. Refractive index, whenever we are finding out refractive index of any medium, it will have no unit. The reason is, in both numerator and denominator, what we have is the velocity of light, and thus it has got the same unit of meter per second. So the same units get cancelled, and therefore in resultant refractive index that we found out has got no unit. We studied about the parallel sided glass slab the last day, and how or what are the different terms and meanings of that. Today we will be doing what is known as a prism. So in your book you will find that they have given the diagram of a prism, something like this, which looks like a triangle, but that is just the front cross section of a prism. If you actually look into a prism in real life, it looks something like this is the front surface, and behind there is some portion which is rectangular, and since it is everything is three-dimensional, this is how the prism looks. So you have a lower rectangular surface here, you have the rectangular surface on these two sides. So there are basically three rectangular sides, and there are two triangular sides. And if you look at this from the front, what you get to see is only the triangle. This is known as the principal cross section of the prism, or the principal section. And at the principal section, what happens when the light falls? Now, if a ray of light falls on a prism like this, say I name this point X. So first thing I will do is draw a normal at X. Drawing a normal means drawing a line that is making 90 degree with the surface of the prism. And this ray here that I have drawn to the point X, say I call it AB. AB is my incident ray. And again, the angle that the incident ray makes with normal is the angle of incidence. Say it travels like this inside the prism and it comes out like this. At this second surface, we will again draw a normal, something that makes 90 degree with the surface of the prism. And here, the angle that the final ray, say I call this ray CD. So I have a ray AB here, which is my incident ray. I have a ray BC, which is my refracted ray, and I have a ray CD, which is my emergent ray. The angle that the emergent ray makes with the normal is called the angle of emergence. And the angle that the refracted ray makes with the first normal is called R1, and the angle that it makes with the second normal is called R2. This is called angle of refraction at the first surface of the prism, and this is called the angle of refraction at the second surface of the prism. Now if there were no prism here, the light would have traveled like this, but because there is a prism, it finally emerges like this. So the angle that is formed between the path that light would have followed if there is no prism and the path that actually light follows upon emergence, that angle here, delta, is known as the angle of deviation. So once again, when you study this, you will need to know the diagram of the prism and also the different terminologies. This triangle here is the principal cross section of the prism. You have an incident ray AB which refracts to form the refracted ray BC and finally comes out of the prism to form the emergent ray CD. The angles which the corresponding ray of light makes with the normal, those are the angle of incidence, angle of emergence and the angle of refraction of the two surfaces. The angle between the emergent ray and the path that light would have followed if there were no refraction, that is called the angle of deviation of the prism. And once again, always remember, when you draw a normal, it should form 90 degree with that particular face of the prism. That brings us to the last topic of this chapter, which is dispersion of light. Now, what is the dispersion of light? So when light travels through a prism, if it is of a single color, then it's fine. But if it is white light basically means that light that we receive from the sun. So if that white light enters a prism, what happens is the refracted and the emergent rays are actually the 7 colors of the rainbow. We get the 7 different colors. And what are the colors? Well, as you know, the order is called VIII. So first we have the violet light here. Then we have got the indigo light, but I actually do not have the color indigo. So let's just draw the or use the same color for both indigo and blue. So that's the VIII, and then we have the VIII. So we have green color of light. So this is the green color of light. Again, I don't have yellow, so let this be yellow as well. So these are the green and yellow. And finally, we have the orange and the red color of light. This is basically the pattern that we get with VIII. This is exactly the colors of the rainbow: violet, indigo, blue, green, yellow, orange, red. And if you look at the order carefully, it is very important to remember the order. At the lowest part we have the violet, and the topmost part we have the red. It is not like red is at the lowest part and violet is at the top. That won't happen. This is the actual order. So when you pass white light through a prism, it breaks apart into 7 constituent colors. And these 7 constituent colors are the 7 colors of the rainbow. This phenomenon where light, white light, is breaking apart into the 7 constituent colors which actually makes of white light, that particular phenomenon is known as dispersion. So actually, white light, the light we receive from the sun, basically is a combination of all these 7 colors. But because all the 7 colors enter our eyes simultaneously, we cannot detect them as separate colors, and we feel that what we are seeing is white light. But actually white light is made of these 7 different colors, and because when it is entering a prism it is undergoing refraction, therefore light of different colors will have different speeds inside the prism, and that is why they will separate out to form what is known as the rainbow in our daily life and spectrum in the sense of a science. In science, this particular 7 colors, the arrangement, the band of colors is called spectrum. Now, when this was first discovered by Isaac Newton, many scientists opposed him and said that light is actually white in color only. There must be something wrong with the prism because of which we are getting the 7 colors. So Einstein did an experiment, Newton did an experiment. He took one prism like this, and next to it he placed another prism like this, exactly opposite. So inverted the prism. So here when white light was incident, it divided into all those 7 colors, and he made all those 7 colors fall onto the second prism. And what happened is, once it fell into the second prism, the 7 colors, they recombined, and the output was once again white light. So he showed clearly that there is nothing wrong with the prism. It is just refraction that is taking place, because ultimately we are again getting white light. Because here we are using one prism, refraction is taking place once, hence we are getting the 7 colors. If you manage to pass it through a second prism, then this entire phenomena is reversed and we get back white light. So that is how we proved that the prism is not producing any colors of itself. And in our daily life, I mean in nature, in reality, it is this dispersion that gives rise to what is called a rainbow. But the source of white light is known to us. In nature, the source of white light is the sun. But who provides the prisms which will divide the color into 7 parts? Well, the water droplets, they act as prisms. Now we know in our atmosphere, the clouds, what are they? They are basically suspensions of water formed around dust particles. So these water droplets, when white light enters the water droplet, they divide into the 7 colors and come out to form the 7 colors of the rainbow. So in nature, it is the water droplets which act as the prism and gives us this beautiful natural phenomenon of rainbow.